Hey guys, okay, we're gonna show you today in this video how to get the resultant of two forces using the parallelogram method. Okay, now check this out. Okay, first step. Okay, step number one is not to go directly into drawing or finding out any other things. No, first step number one is to get a rough sketch of the parallelogram law, so you can see both the forces are starting from the same point, so your parallelogram will look something like this. Okay, so what would be a suitable scale for you to use? If I were to use 1 cm to represent 10 newtons, check this out. Okay, the width of my paper is only about 21 cm. Okay, 21 cm. Okay, if I were to have 1 cm to represent 10 Newton, this force here will be 14 centimeters long. Even at a slight angle, if I were to roughly just replicate this a little bit here, okay, 14 cm is more than, you can see, it's more than half the paper, right? Okay, so what I would do is to reduce that scale by half. So instead of 1 cm to 10 newtons, I will use 1 cm to 20 newtons. Okay, so 140 newtons here will convert to roughly about not roughly, yeah, but exactly 7 centimeters. So if I were to just put this, push this down here, roughly around this angle. You can start off any angle, but okay, just to take note, you're gonna start off the point from as far left of the page as possible, because you're gonna move in this direction. If you were to start, imagine you were to start something like this, your parallelogram is going to fall out of the paper, right? Correct. So start to the left, somewhere in the middle, okay? Because it's going to go up, and the corresponding 80 newtons where it's going to go down. So somewhere in the middle towards the left. Okay, so how many cm did I say? 7 cm. Okay, so 7 centimeters. Where's my force over here? So roughly, not roughly, sorry, exactly, I keep using that. Okay, exactly 7 centimeters. That will represent 140 newtons. The other side, 80 degrees first. So just to measure, putting my protractor at the start. Making sure it's parallel first. Okay, putting it here. Okay, put another component force. 80 degrees. Okay, I think. Wow, boom. That's great. Exactly 80 degrees, but I need to make sure it's also 4 centimeters, because 80 divided by 20 gives me 4 centimeters this side. Okay, so just to make it parallel first. So 4 centimeters. Okay, oh yeah, almost. I almost hit it. Just stretch it to 4 centimeters long. So you can see that's 7 cm by 4 cm. So 7 by 4. Okay, so what I'll do next is to draw a parallelogram. You can draw a parallelogram by putting it here and then measuring about 110 degrees. Because since this is 80, interior angles will be 110. So you can actually draw the same length and do the same to the other side. Okay. What I'm going to do is I'm going to, since I'm doing this on a drawing, on electronic drawing, I will just copy and paste. Immediately I get two parallel lines, but it's important when you draw the lines, they are different, okay, in the sense that to show that they are only parallel lines and not component forces, they need to be dotted, as well as you need to remove all the arrows. Okay, so remove arrowheads and boom, that's right. Okay, finally just put in your uh, put in your resultant force. You see, my resultant force is just from the start all the way to the end of the parallelogram. Okay, measure that resultant force, and that resultant force will be 8.6 cm. So my answer will be magnitude of resultant force 8.6 cm times 20, which gives me uh, 17.272 newtons. Okay, so this will be my answer. Direction of resultant force. Okay, now, oops, sorry about that. Okay, direction of resultant force. This is my resultant force. You don't use the word east or north, south, because first and foremost in the question they didn't tell you where is north. The only thing you know, the only direction you can give is relative to the current forces over here. So let's just put our protractor here. Okay, you can measure this. How many is this? This is 27 degrees. So 27 degrees clockwise from the top force. The top force happens to be the 140 newtons force. So it's 27 degrees clockwise from 140, 140 newton force. Okay, so just degrees. I can change it to just put in a symbol for degrees. Symbol. More symbols. And there you are. Okay, 27 degrees clockwise from 140 Newton force, and that's it. Okay, so just to recap, first thing to do in your parallelogram law rule, you got to take a find out nice suitable scale. After a nice suitable scale, you know where to start that point. If your parallelogram is going to go to the right, so start as far to the left as possible, so you'll always have more than enough forces, more than enough space. Okay, the actual forces 140 and 80 newtons always use a single arrow, and the final resultant use double arrow. To complete the parallelogram, use the dotted lines over here, and the magnitude of the resultant. You can just measure it off and multiply it by the scale over here, 20 newtons. So you get this, and the directional resultant force, just to take note, is always relative to one of the forces. I can choose this 27 degrees clockwise from the top 140 Newton force, or it can actually be from the bottom force also. So if it's a bottom force, it will go anti-clockwise, okay? Because this is the pivot, it goes anti-clockwise, so it will be 90 minus 27, there will be 63 degrees counterclockwise. All right, so that's it for parallelogram law, for parallelogram rule. I hope you enjoyed this video. All right, so see you guys again.